when we graph the inverse, they're reflections over the y equals x line. So another way for us to self-check, this is not a way to prove that they're inverse of each other, but it's a way to self-check, is to quickly graph them in y equals mode and see if you could fold on the y equals x line. So we're supposed to do x cubed and the cube root. Is that what the two functions are? Okay. So in the first one, let's just do x raised to the third power. The easiest way to type in raised to the 1/3 power is to go caret. Some of you may have to hit the caret symbol with parentheses 1/3. I'm just going to raise it to the 1 divided by 3 power. My calculator just raised it to 1/3. But you may have to put parentheses around yours. And when you graph them, you get something that looks like that. Right? So that's your x cubed and your cube root, something like that. And then what they're asking us to do is look, is it a reflection over y equals x? So we could put that in there. Now, depending on how your screen is looking, it might help if you zoom. You don't have to, but if you zoom square. What would happen if I fold on the y equals x line? Would I end up matching the graph over here? Yeah. That's a quick visual, and that will help some of you understand whether or not you found the correct inverse. But hear me when I say it does not prove it. If I say verify your results or prove that you found the correct inverse, you cannot sketch me a graph. It just doesn't work. Okay? The one-to-one property. Test to see if something is one-to-one. You're supposed to use the one-to-one property to determine whether or not there is an inverse function to find. So I can remember back to calculus courses and whatnot that I took in college, and they would ask you to find the inverse. And if you did not check for one-to-one, you would, some of these problems would get y by itself and then flip-flop your x's and y's and all this stuff would take 3 or 4 minutes of work time, and then you get done, you're like, oh, well, this isn't even a function, so why, I just wasted all my time. So what they would do, they would trick you. They would say, find the inverse if there is one. You should check for one-to-one first. The easiest way is to do what we call the horizontal line test. So, we already have what's called the vertical line test. What does the vertical line test tell us? If something's a function or not. It's telling us for every x, is there only one y on the function, right? For every input, is there only one output? if it would fail the vertical line test, what would happen in the case of the horizontal line test? So when something, if something fails a vertical line test, it has a y1 and a y2, right? For one x, there's a y1 and a y2. If we reverse this now, the y's become x's. And the x becomes a y. Okay? So the horizontal line test is testing for every y, do I have one or do I have two x's? If I, for every y, yeah, I said that right? For every y, is there one or two x's? If there are two x's, what's going to happen when I find the inverse function? Well, it wouldn't be an inverse because there would be two y's for the one x. So that's the idea. It's kind of weird, it's kind of backwards. You have to be able to prove whether something's one-to-one. To do that, you're going to set 3a plus 5 equal to 3b plus 5. By plugging in a and b, what am I implying? Mathematically, what am I implying? That as far as inputs go, what did I put in for x? Was I putting in the same input or different inputs? By writing it a and b, I'm making the implication that, you know, one group is plugging in something and another group's plugging in something else, right? By setting them equal, what implication am I making? That by plugging in A and B, they're producing the same output. So what I've written is, for two different inputs, I'm coming up with the same output. So for two different inputs, I'm coming up with the same output. That's what that 3a equals 3a plus 5, 3b plus 5 is equal. I've really set this up, haven't I? Okay. Subtract 5 on both sides. Now what? Divide by 3 on both sides. What does that tell me? So what it was is, it's like I split the room in half and I tell you, you guys go over there and work. And I say, pick a number to plug into your function. And then I tell you guys, go over here and work. And I say, pick a number to plug into your function. So your two groups are working independently. This implies that you guys pick two different numbers. But what happens is, at the end of this, we're saying what? That both groups actually pick the same input. That's really what this is telling us. So it's not this situation. It was, you both came up with the same output, and the only way that's going to happen is if you have the same. You have the same output, and the only way it's going to happen is if you have the same input. So indeed, this function is one-to-one. That's what it tells us. It means one-to-one. When we thought we were putting in two different inputs to get the same output, the only way it can happen is if A and B are the same. So that tells us the function can only produce one output for every input. What would it look like if it was not one-to-one? I normally don't do this problem with you guys, but let's take a look at it. if I do the same process, I can go a minus 5 squared is equal to b minus 5 squared, and you square root both sides. Because you're square rooting both sides, you have to put plus or minus back in there. Now you can. Now you get into a situation where you have a minus 5 is equal to the b minus 5, or the a minus 5 is equal to the negative b minus 5. So at the very end of this, what's going to happen? Can you get a equal to b? No. So you run into some issues there. So when you look at x minus 5 quantity squared, what did we learn the other day? It's going to be like that. If I draw a horizontal line across there for this y value, for that particular y value, right, I'm having two different inputs can produce it. So it's not passing the one-to-one test, the horizontal line test. Now, if you pictured all your x's and y's flip-flopping, you would end up with a parabola tipped on its side. Does a parabola tipped on its side pass the vertical line test? No. So the inverse would not be a function. So what the one-to-one test is going to tell us is stop. You don't even need to go looking for an inverse because there isn't going to be one. The easiest way is probably to do the horizontal line test. This is the algebraic way of proving it. Maybe if the graph is too difficult to see or something. So, just so I should write that on here in case somebody watches this later on. What we would have to do in a problem like this is restrict the domain to be x's are less than or equal to 5, and so what they would do is split we'd split the graph, like get rid of anything bigger than 5. Now does that left-hand side of the parabola pass the horizontal line test? Yes. So if I go to look for an inverse, you know, it'd be kind of like a square root looking function that would pass the vertical line test. So we don't do anything with restricted domains, so you don't have to worry about that.